Hey guys, Mr. Riz here, and I'm here to help you out on the Chapter 10 review. So our last test here, reviewing for that. Okay, so we'll go over this packet here, and this is going to be very similar to you guys' test. So keep that in mind. Should be a nice, easy test for you guys to wrap up the year. All right, so we got matrices R, S, and T, and they are all 3 by 3 matrices. Which statements are true? Select all that apply. So hopefully you guys remember some of the rules with matrices. But the biggest thing here I want to make sure that you guys understand is that, if you don't remember some of the rules, you can kind of find your way through that. Okay, so one thing we could do is we could just use our graphing calculator here and we could make up examples to see if these are true. I hopefully you guys remember A times B is not the same thing as B times A, but maybe, all these other rules that are a little bit more complicated might mess up. So let's just call these A, B, and C, just to keep everything, because I think our matrix C, I think we might have R, S, and T. No, we don't. We just have to J. So let's go through and let's make up 3 random 3 by 3 matrices. So here we go. We'll just do 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll just keep it easy. That's matrix A. All right. And then we'll do second quit. We'll go matrix and we'll edit matrix B. And we'll make that a 3 by 3 as well. And just to make sure that these are all different, so count do 10, 11, 12, 13, 14, 15, 16, 17, 18. I put a bunch of ones in there. I think I was typing too quick. 14, 15, 16. So I could use ones, but ones might mess up with some identity rules. So just keeping these all different numbers. And then, you know what I'm going to do here, second quit, matrix C, we'll do the same thing. And 3 by 3, except for I'm going to put some random 0. So I'll put 5, I'll put 2, 8, 4, 6, 5, 1, 2, 1. Just to make sure that if I kept going bigger, I'm thinking my answers might be super huge and just want to avoid that. Okay, so if we want to see is ST plus TT, is that the same thing as S times T plus T? We're just going to type that into the calculator. Now it takes a second here. We got to do, let's say matrix S is B, is matrix B times matrix C. Oh, matrix C plus matrix C times matrix C. What is that? Okay, we get this answer here. I don't need to write this down, or I'm just going to leave it in the calculator. What I'm going to do see is second matrix, is that the same as matrix B times parenthesis matrix C plus matrix C. All right. We get an error here, so clearly it is not the same thing. So we can go ahead. What does it say? Invalid dimensions. Yeah. Because we could have done. And then what if we did matrix B times answer? Yeah, we would have got a different answer anyways. Okay. Next up, we'll just go through and try all these. So we got to just kind of be careful, I guess, with the addition is T plus R. I didn't even think about this one here. This one doesn't even make sense, T times R. So that one's not going to work. What about, is RS times T the same thing as T times RS? That one's not going to work either. All right, is RS times T the same thing as R times ST? And let's just go through and see if we can do that. So, one thing to do, matrix here, that'd be matrix A times matrix B. And we can times that by matrix C. You know what I'm just doing, looking at. Oh, I did see, I do have a mistake here. I already printed that off. This should be TS, because that one should work out. The distributive property does work out. All right, so here's our answer for RS times T. We're going to see is that the same thing as R times ST. So we got to do matrix B times matrix C, and then do matrix A times that answer. Let's see if we get the same thing. Actually, is it looking pretty good? Yeah, that's the same thing. So the answer should be B and D on this one here, and we can use that to kind of double check. Okay. Next, easier stuff. So here we go. If we are going to use the rows in matrix B to represent the amount of prices for small bouquets and large bouquets, so rows are small and then large, you might want to go ahead and write that on here to help you out. So we got small, and then we got large, and then we got tulips, roses, and daisies. Okay, if we want to find just 4% of this to use scalar multiplication. Okay, so all we need to do in this one, I guess we didn't need to write that down. We just need to take each box here and times it by 0.04. So we're just going to do like 25 times 0.04. So we're just going to go through with the calculator, multiply every single number that we get by 0.04. Okay, so calculator time. I like using this one here, the hand calculator. All right, what's 15 times 0.04? It comes out to be 0.6, so 60 cents. All right, 30 would be $1.20, twice as much as that. All right, what's 20 times 0.04? That would be 80 cents. All right, what's 25 times 0.04? That'd be $1. All right, 50 would be $2, just twice as much as that. What's 35 times 0.04? That'd be $1.40. There we go. So there's answer 2. Pretty easy. All right, next, this is the one where you want to write down matrix V, the entries for the number of loaves and loaves of bread at a bakery. Why that was difficult to say. All right, column 1 represents wheat, and column 2 represents rye. Row 1 represents small, and row 2 represents large. What does the number in position 2, 2, so that's row 2, column 2. I guess if you didn't know, you would have got pretty lucky here with 2, 2. What does that represent? So it's going to be 9. All right, we're going to look at that's 9 rye large, so 9 large rye loaves. All right, next it says write the system equation represented by the matrices here. Okay, so technically what we would do is we take this row times this column and set it equal to this, so or to the first number here. So it'd be 3 times x plus 5 times y equals 13. Now the easy way is just to go through this first column is the x's, the next column is the y's, just set it equal to the answer. And then we do the same process here. We got 2x minus 2y or plus negative 2y equals negative 2. All right, and so that's that problem. All you had to do is just write that system of equation. You don't need to do anything else. Okay, hopefully the first page isn't too bad. All right, next page, working on some just simple rules here. We got adding and subtracting here. All right, so find y minus x. So if we were going to subtract the matrices, we're going to subtract each column here. We'll start with 3 minus 2, that's 1. We'll go to the next element, negative 1 minus 6, it's negative 7. All right, 4 minus negative 5, so that'd be 4 plus 5, that's 9. And 6 minus negative 1, be 6 plus 1 or 7. There we go, piece of cake. All right, next problem, 5x times y. So that'd be 2, 6, negative 5, negative 1. And we're going to times it by 3, negative 1, 4, 6. All right, so when we do this, remember we do rows times column. We should get a 2 by 2 matrix in the end here. All right, so first one we're going to do first row by first column. So we're going to do 2 times 3 plus 6 times 4. All right, so 2 times 3 is 6, plus 6 times 4 is 24, 6 plus 24 is 30. All right, we're going to keep that process going here. We're going to do row 1 by column 2. So we got 2 times negative 1 plus 6 times 6. So that's -2 plus 36. That'd be 34. All right, then we're going to do row 2 by column 1. All right, so -5 times 3 plus -1 times 4. All right, so that'd be -15 minus 4. That'd be -19. And then lastly, we're going to do row 2, column 2, -5 times -1 plus -1 times 6. So that'd be 5 minus 6, that'd be -1. There's our answer here. Now what you can always do here, I want you guys to show your work in case you make a simple mistake, but we can double check all of our answers on the calculator here. And so what we could do here, just using the calculator, go to our matrix, let's edit matrix A, make it a 2 by 2, and just type in the numbers 2, 6, -5, -1. All right, and then we'll also do matrix B, we'll edit that. It's a 2 by 2, it's a 3, -1, 4, 6. All right, and we can just do matrix A for matrix X and then times matrix B for matrix Y. There we go. Did we get the right answer? We sure did. So use that to check your work. All right, next we got the additive identity matrix here. All right, find matrix X plus matrix Y. Well, if we look at this here, matrix Y is nothing but zeros. If we're going to add that to matrix X, it will not change matrix X at all. All right, there we go, piece of cake. All right, next, in order, find which matrix has an inverse. So in order to have an inverse, the cross multiplies must not be the same thing because that messes up with the discriminant here. So we're going to see the 6 times -6, is that the same thing as -4 times -9? All right, and then we would get -36 and +36, and those are two different numbers. That works. All right, just to double check here with the other ones here, -4 times 6, we're going to see is that the same thing as -3 times 8. That's -24, -24. Okay, those are the same numbers. That won't work out. And even right here, we got 4 times 4, that's 16. 8 times 2, that's 16. All right, that doesn't work out. And lastly, 3 times -7 is -21. 7 times -3 is also -21. They got to be different numbers. Positive and negatives are technically different numbers. And so A is the only one that has an inverse. Okay, hopefully not too bad. All right, last problems here. These are the ones that are a little bit tricky. All right, so a company that makes cardigan and pullover sweaters last week, the company spent $18,500 on labor and $16,000 on material. Let's C represent the number of cardigans produced and P represent the number of pullovers. Complete the matrix and then solve for C and P. Okay, so what we have here is, let's look at this matrix here. We got the labor here and the materials. We can call this C and call this P. We know that if we had 15 cardigans and 11 pullovers, it would have to equal, oh, you know what? I just realized here, I need to edit this. This should have delete column. I'm probably going to have to print these off again. Oh, well. That should just be one blank. Let me go ahead and try that again. If we had 15 cardigans and 11 pullovers, we'd have a total of 5,000. And so, okay, we probably should maybe even be easier to write this over here. This should be 1511, and then CP would equal 18,500. And then 12 for the cardigans and 10 times the P here would equal 16,000. Okay. So remember, there's kind of two different ways we can do this problem here. Is we could go through and set this up and say 15C plus 11P equals 18,500. And then do 12C plus 10P equals 16,000 and do like elimination or something like that. Or the easiest way to remember, if we want to get out C and P by itself, if we want to get the matrix C times P, what we need to do is, if we call this matrix A here, and this is matrix B, we're going to have to do the inverse of A times B. So let's figure out what that inverse is. And so if you're going to do it this way, I want you to show me, okay, what is the inverse of A? And okay, calculator time. This is where it becomes really useful to know how to use the calculator. Let's go through second matrix. That matrix A, we'll edit that. It's a 2 by 2 matrix. And it's 15, 11, 12, 10. Just realized that I didn't type that one in. 15, 11, 12, 10. And you know what? The same thing we're going to do. We're going to mess with matrix B here. That is a 2 row, 1 column. So 18,500, 16,000. First thing we're going to do is, okay, go to matrix and we're going to go to A. We're going to press this button here with the matrix to get the inverse. And if that looks scary, we're going to just press math, enter, enter. It will turn it to fractions. So what we need to do here is to figure out matrix A is 5/9, negative 11/18, 2/3, and 5/6. What we need to do here, I'm going to have to kind of move this so I have room. We're going to have to take that matrix here, 5/9, negative 11/18, 2/3, and 5/6, and we're going to have to multiply it by matrix B, which is just 18,500, 16,000. Okay, and this is why calculator is super nice, because we can just go ahead and have it do that. So we can take that answer here that we got and times it by second matrix B, and there's our answer, 500 and 1,000. So we, scrolled on me here a little bit. So basically we get the matrix CP is equal to 500 and 1,000. So that means we got 500 cardigans and 1,000 pullovers. Okay. Next, what we want to do here is to take this secret message and to decrypt it. So we have a key here, which is 13, negative 24. The first thing that we want to do is to find the inverse. And easiest way to do this is to use the calculator here. So go to matrix here. We're going to edit matrix A. It's a 2 by 2, so don't need to change much. It's 1, 3, negative 2, 4. It's our matrix. All right, and we'll just do second matrix A. And we'll do find the inverse by pressing that button. It does that 1 over discriminant. We can put those decimals down, or we can press math, and then we can go through and where is it? Well, just math, enter, enter, right? What am I thinking about? Okay, so here is our matrix, our inverse matrix here. Our key inverse is 2/5, negative 3/10, 1/5, 1/10. Okay, so now to decrypt the message, this is technically what we're going to do here, is we're going to break these up into 2 by 2 matrices. We're going to multiply each one of them by the key, or we're going to do the key inverse times this one. So the first thing we would do here is probably take our key inverse, so negative 2/5, negative 3/10, and then 1/5, 1/10. We're going to multiply this by the matrix. Okay, hold on 1 second. I need to do this. Sorry. Somebody waiting by the door. All right, actually got that backwards here. What we need to do is to do the decrypted message, negative 2381, and times it by the key. Okay, so technically this is what we would do. We would take negative 2381, we would take the first row by the first column, so we'd have negative 23 times 2/5, and then plus 81 times 1/5. And let's see, what do we get for that first number there? Let's see, that'd be crazy here. Or what we can do is to use the calculator. So in our calculator here, we already have matrix A as the key, and we already have it set up as key inverse. We're going to just kind of get a little tricky here. So let's go through our matrix here. We'll make matrix B here. We'll edit it. We'll make that a 2 by, actually it's a 1 by 2 matrix, and it's negative 23, 81. All right. Actually, let's do it the long way. I'd rather have you guys show the work here. Okay, so, we can multiply it, but basically I want to show you guys, or you guys should show that you're multiplying. All right, so what's negative 23 times 2/5? We get negative 0.92, and then 81 times 1/5, 16.2. If we add those together, we get 7. All right, and then we're going to do the same thing. We'll do negative 23, but we'll times by negative 3/10, and then 81 times 1/10. All right, so negative 23 times negative 3/10 is 6.9, and then this would be 8.1. Add them together, that's 15. So 1715 are our first answer. Okay, so we rinse and repeat. Okay, so we'll do this again, but with negative 1428 and 2/5, negative 3/10, 1/5, 1/10. All right, so negative 14 and times negative 2/5, and then we got 28 times 1/5. All right, negative 14 times 2 divided by 5 is negative 5.6 or 5.6, and then 28 times 1/5 is 5.6. All right, and that would be 0 if we add them together. And so then we rinse repeat, negative 14 times negative 3/10, and then 28 times 1/10. All right, negative 14 times negative 3/10 is 4.2, and this would be 2.8. Add them together, that would be 7. Okay, 2 done, 2 more to go. We got negative 2351. And we're going to go through this process again. Okay, so negative 23. Oh, my calculator's looking weird. Negative 23 times 2/5. All right, that's negative 9.2. Oh yeah, we already did that one. And then 51 times 1/5 is 10.2. Add them together, that's just straight up 1. All right, so negative 23 times negative 3/10. All right, I know that's 6.9. And then 51 times 1/10, it's 5.1. If we add them together, that's 12. Okay, 1 more to go. Kind of running out of room, so I'm just going to write this here. We got 7, 15, 0, 7, 1, 12. All right, last one here. We would have to do negative 33 times 91 times our key. All right, so negative 33 times 2/5 plus 91 times 1/5. What are we looking at there? Negative 33 times 2 divided by 5 is negative 13.2. And then 91 times 1/5 is 18.2. Add them together, that is just 5. All right, last one, negative 33 times negative 3/10, and then 91 times 1/10. Let's see, 33 times 3 divided by 10, that is 9.9 plus 9.1, add them together, that's what, 19? All right, so what letters are these? What is the secret message? All right, 7, if we look at it, it's a G, and then 15 is an O, 0 is a space, 7 is a G, 1 is an A, 12 is an L, 5 is an E, and 19 is an S. Go Gales. All right, we did it. Okay, so there's the review. You guys can see what this test hopefully isn't going to be too bad, especially if you know how to use the calculator. I'll show you work, and this should be a pretty easy test. All right, guys, have a good one. See you later.